this problem, we have to evaluate the integral 0 to 1, 1 by 1 plus x square dx by using Simpson's one-third rule, dividing into 6 equal parts. Now here, n is given as 6 and the integral is 0 to 1, 1 by 1 plus x square dx, whereas a is 0 and b is 1. Let us calculate h. h is nothing but b minus a by n, which is 1 by 6. In order to calculate this integral by Simpson's rule, let us find the values, that means Simpson's variables. Let us take x and y. So x0, x1, x2, x3, x4, x5 and x6, so that the total intervals will be 6. Now x0 will be 0, x1 will be plus 1 by 6, that is 1 by 6, x2 will be 2 by 6, what is 1 by 3, x3 will be 3 by 6, that is 1 by 2. Now x4 will be 4 by 6, that is 2 by 3, x5 will be 5 by 6 and x6 will be 6 by 6, that is 1. Now let us substitute these values in the given function to evaluate y0, y1 and so on. So if I substitute x0 as 0, then y0 will be 0 and y1 will be 0.162. Similarly y2 is 0.3, y3 is 0.4, y4 will be 0.491, 461 and y5 will be 0.491 and y6 will be 0.5. Now 0 to 1 dx by 1 plus x square, Simpson's rule is nothing but h by 3 into first term plus last term, which is y0 plus y6 plus 4 times of the values in the even places, that is y1 plus y3 plus y5 plus 2 times the values in the odd places, so y2 plus y6, y2 plus y4, because we have taken y6 already. So let us substitute the values. H is 1 by 6 and by 3, so 1 by 18, and y0 plus y6, which is 0 plus 0.5 plus 4 into y1, y1 is 0.162 plus y3 plus y3, the value of y3 is 0.4, y5 is 0.491 plus 2 times of y2 plus y4, which is nothing but 0.3 plus 0.461. If we simplify, then the value will be 0.34634, which is option B.
Is the Z transform of the real and right-sided sequence x of n has two poles, and one of them is at z equals to e power z pi by 2, and there are two zeros at the horizon. If x of 1 equals to 1, then which one of the following is true? That is, here x of z can be written as so. From this one, if we simplify this one, we will get z square plus 1, that is k z square. From the given data, we know that x of z at z equals to 1 equals to 1. If we solve k by 2, that is k equals to 2. So from this one, 2z square by z square plus 1, we know that from the right sided sequence means it is that particular x of n is multiplied with u of n, whose ROC is mod z greater than 1. Hence, its ROC is mod z greater than 1, which is option D is correct. Question is, G-type master slave JK flip-flop is shown in figure along with the clock and the input waveform. The QN output of the flip-flop was 0 initially. Identify the correct waveform for the output. See, here the flip-flops we used here, they change its next state. The means its response is going to change to the positive transition of the clock. So the input waveform is given in this way and the clock is given is like this. So we have to draw the waveforms for Q0 and Q1. Q1 is the final output of the JK flip-flop, which is shown in the figure. So for the Q0, if we draw the waveform, is going to be like this, because If input is 0, the output remains as it is. If input is 1, the output is going to toggle, means complement of the previous state. Here, similarly for Q1, it depends upon the Q0. So, the final output waveform is Q1, this one. In the circuit shown below, the value of voltage at point P is 12 volts. This is a voltage at point P is 12 ohms. The voltage between gate and source is minus 2 ohms, the value of our n kilo ohms. See, this is the n type of MOSFET. Means we know that when we are looking from the gate, the input impedance of the MOSFET is infinite. So Ig equals to 0. Now, here we know ID equals to 2 milliamps from the given data. That is 16 minus 12 by 2K. We got ID equals to 2 milliamps. Now Vg equals to Vgs plus IDRs. Now Vgs is equals to minus 2 volts, which is given in the data. So ID equals to 2 milliamps, Rs equals to 4. So this is Vg equals to 6 volts. Now 6 volts, 16 into 42 divided by 42 plus R. So 42 plus R equals to 112. So R equals to 112 minus 42. So it is equals to 70 kilo ohms. Hence option D is correct. Is when an input voltage Vi of the form shown is applied to the circuit given below, the output voltage is of the form. Here this is A, this is K. The diode is going to be in the conducting mode as long as Vk less than Va. Then D, that is diode, is on. That means V0 is 3 volts if it is ideal. But if it is practical, V0 is 2.3 volts if it is practical. So if the diode is not there, even means if the battery 3 volts battery is not there, then the waveform we will get is if it is ideal. If it is practical, if the diode is ideal, we will get the waveform like this. This is for ideal waveform. But if it is a practical one, so if you find out the output waveform for this circuit, you will get both option B if it is ideal, option C if it is practical. Hence option C should be considered because both are given. So option C is right.